welcome to today's class. I am Promise, and in today's video I am going to be introducing you guys to something called source control, and later on into this video I am going to show you guys how you can create your GitHub accounts and set up Git on your Windows machine. Alright, but before we do that, actually I would love to ask two questions. I don't know if you've heard about working remotely before, or do you have an idea on how remote teams can effectively collaborate in building projects? Okay, but first things first, right? When we say working remotely, it simply means, flexible working arrangement that allows employees to work from remote locations outside of corporate offices. Okay, so you must have heard of persons saying they work from their homes. All right, so that's just an idea, what remote jobs are all about. Okay, so I don't know if you've actually wondered how possibly, can developers in different remote locations work on a particular project and then, it comes out all well. Okay, how can developers from different locations build a project? Say they are building a website or they are building an application, and their source code, their code is not, conflicting with one another. How can they possibly achieve this? All right, so during the course of today's video, we are going to see, how this can be done and know, the best technology that is being used right now, in what's called collaboration. All right, because this topic is a very, very important topic that, every developer today must really get to understand what source control or version control, is all about. So having the knowledge of source control, how it works in particular, is very, very important as a developer, and it cannot be overemphasized. All right, and this is because as a developer, one of the things you will do a lot is collaborating with other developers. All right, and the knowledge of source control has become one of those major requirements any developer must possess in order to get hired in the tech industry. All right, so this topic is very, very important, and I want you, to stay glued and pay as much attention, as you can. So let's get started. So what exactly is source control? So source control refers to tracking and managing changes to code in a repository. All right, and this ensures that developers are always working on the right version of source code, and this is very important. All right, because there's no denying the value of keeping track to who made changes to the code and when, when developers are working, as a team. All right, so this actually helps to track down the source of bugs. Right, so by bugs I mean errors, and it prevents one developer from overwriting changes made by another. All right, which will actually result in what's called conflicts. Okay, and this means in a nutshell that version control basically helps you to keep your code under control. All right, I think that makes sense. Okay, so let's continue with the reading here. It says open source projects most times make use of version control in developing their projects. So anytime you hear open source, what it simply means, all right, is that the source code, and by source code I mean the code written by a developer. Right, so the code you write as a developer or as a programmer is referred to as source code. All right, so don't let it throw you off. So when the source code of a project is available, right, when there is no restriction to who can view it, all right, when it's available to the general public, such projects are referred to as open source projects. On the other hand, when you hear projects being termed closed source, it means that the source code is hidden or restricted from the public to use. I think that makes sense. All right, now one of the major examples that can be used here is the Android operating system and the Apple's iOS operating system. All right, so the Android operating system, for instance, is open source. Okay, and that's why, for instance, you get to see Infinix running on Android, Itel running on Android, Xiaomi running on Android, Samsung running on Android, Injo running on Android, and many, many others running on the Android operating system. And this is because the source code for Android OS is available to the public. Okay, but on the other hand, the iOS, all right, owned by Apple, the source code is not available to the public at all. And that's why you see that the iOS operating system runs only on just the iPhones. So I think this makes sense, right? So let's continue. So it says here that open source projects most times make use of version control in developing their project, and this is the reason why we get to see lots of collaboration happening in open source project, because it's available, so other developers can make changes to it, other developers can contribute to it, and then there can be faster updates and upgrades being made in such a project. Okay, now we mentioned earlier that source control refers to tracking and managing changes to code in a repository. So what exactly is a repository? So a repository is simply a central location in which data is stored and managed. Okay, so you can think of a repository as a storage kind of system. Okay, and repository can either be a local repository or a remote repository. And when we say a repository is local, it simply means that the Git repository is stored on your computer. All right, and when we say a repository is remote, we are saying that the Git repository is stored on some remote computer. So that computer is not around your immediate environment. The computer might be in a different country, it might be in a different continent. So that's what a remote repository is. No worries, as we progress in this video, you actually get to see how we can link a local repository, to a remote repository. Okay, now let's see, why exactly do we need version control systems? One, streamlining the development process, as multiple people can work simultaneously on a single project, and this is so important and this is very powerful, right? Because say for instance it takes one developer to build a system that will last over 3 months. Okay, on the other hand, if that same project is given to 3 developers that are in the same skill level, right, they will be able to beat that time to a month or less. Why? Because multiple persons are working on that particular project, so it streamlines the development process a lot. All right, which is very important in the software industry and in the IT world at large. It brings about faster development. Okay, point 2, management of code for multiple projects. So version control systems helps you to manage your project a lot. It helps you to manage your source code a lot. So, and then point 3 here, it says version control provides access to the historical versions of a project, and this is so powerful. All right, now as a developer, you might be working on a project, all right, and it's running perfectly fine. Okay, and you might want to add a new feature into that project you are working on. Okay, and in the process of doing that, bugs can come about, right? You can have errors, you can have something called errors that can break your code. Okay, like it can ruin your code entirely, and that would be a mess for you. Okay, so what you could do when you've employed version control in the project you are working on, you could simply roll back to the previous version that was working perfectly fine, right? And you will not have anything to do with those errors that can break your code anymore. Okay, you must have maybe downloaded some apps or downloaded some updates to some apps, and you realize that the updates are buggy. They are worse than the previous version of the app you had before. Do you understand what this means? So it's very important that you understand how version control helps to provide access to historical versions, because you could just simply roll back, right? You could roll back to the previous state that your code was working perfectly well. Okay, and this is insurance against computer crashes and data loss, and if any mistake is made, you can easily roll back to a previous version. Okay, so it helps in recovery in case of any disaster or unforeseen or contingent situations. Okay, another instance that can be made too is, imagine you are building a project for a client, right? And you've been building that project for over 9 months, and you are already at the end of that timeline to finish that project. So say at about the 8th month in working on that project, and an unfortunate situation just happened, right? Maybe your computer just got submerged into water, right, and fried your motherboard entirely. or say, thieves took your laptop away, okay, that would simply mean you have lost over 8 months of work, and of course many other things, many other data in your computer. But the good news about the version control is that having version control integrated into a project, right, all you need to do is to get a new PC, and then you can simply just pull everything you've worked on back to the last state that it was. And that's so amazing. That's so amazing. So you don't have room to give, your client stories that this will happen, this will happen. You can just finish your project, be a trustworthy developer, and you deliver your project on time, right? So that's why we need version control systems. So next, let's look at the types of version control systems. So one, we have the distributed version control, right? And some examples there are the Mercurial, we have Git, and then we have Bazaar. And two, we have the centralized version control systems. So we have something called CVS, which is concurrent version systems. We have SVN, which is subversion, and then we have Perforce. Okay, now amongst this variety of version control systems, what we are going to be focusing on is Git. All right, is Git, and let's see what exactly Git is all about. So what is Git? So Git is a free and open source distributed version control system developed by the Linux rockstar Linus Torvalds. Alright, Git was designed to handle everything from small to very large projects with speed and efficiency. So we are seeing here where we are embracing Git, because it helps you to work on projects with speed and efficiency, which is a very, very important factor in the software industry. Okay, now where Git really shines is in the transaction speed. I tell you, because it's a lot quicker compared to any other solution. And if your team, for instance, is working remotely, then anything that decreases the safe time is a major advantage. All right, so let's look at some Git hosting services. They include Bitbucket, we have GitHub, we have GitLab, we have Perforce, we have Beanstalk, we have Amazon AWS Code Commit, we have Codebase, we have Microsoft Azure DevOps, SourceForge, Gerrit, and many more. All right, but amongst this lineup of the Git hosting services, we are going to be looking at GitHub in particular. So the question really is, why are we focusing on GitHub? What advantage does GitHub have over this lineup of Git hosting services? So let's look at GitHub very quickly. All right, so GitHub is a web-based hosting service for Git repositories. Already we mentioned that repositories can be seen as storage systems. Okay, now another word that could be interchanged for repositories, all right, is repos. So you can use Git repo. Okay, that's a short term for the word repositories. Okay, so nowadays GitHub is the largest online storage space of collaborative works that exists in the world. So it's the big guy there. All right, GitHub has become the go-to hosting platform for projects using Git. So a lot of persons, a lot of developers, they embrace GitHub, amongst other hosting platforms being used by Git. All right, so in this section of the video, we are going to be looking at this installation and the setup. Okay, so we're going to be seeing how we can install Git on our computer, and also how we can set it up, and then of course set up our GitHub account. All right, so for the Windows users, you could go to gitforwindows.org. all right, and then for the Linux users, you could go to git-scm.com/download/linux, and then for the Mac users, you could go to git-scm.com/download/Mac. But as a matter of fact, Git comes installed by default on most Mac and Linux machines, so that's an advantage on this side. All right, but for the purpose of this video, okay, we are going to be installing Git on the Windows device. So let's get straight into that right now. Okay, so the moment you get onto gitforwindows.org, right, you would see this download button here. Quite straightforward to get this. So just tap on the download button, and you have this file downloaded to your device. Okay, so once that is done, you can double click on it, enable yes, right, so you go next. So you just keep going on next, alright, because many of the things you would need, are already ticked for you, for an average user. Okay, so just keep going next, and then install. Okay, so you wait for Git to install completely on your device. Alright, now, so like we've already mentioned, okay, Git is one of these tools that we have available, alright, to foster collaboration. Okay, and trust me on this, you really might not appreciate its benefits right now, not until you begin to actually work on some kind of project. Okay, so let's just wait for Git to be installed. Alright, and we're almost done. Okay, so Git has been successfully installed on our Windows machine. Alright, so next thing we are going to do is that we are going to add the path to something called the environment variables. And the reason we are doing this, alright, is so that we can run the Git command from anywhere within our computer, alright, from any directory within our computer. Adding the path of our Git will make it available on every directory, alright, so we can use it from our terminal and run Git commands anywhere. No problem. As we go along with this course, you get to understand these terminologies and what exactly this whole thing means. Okay, so Git was installed to the program files Git folder. So you come in there, go to bin, which stands for binary, and then you copy this. So you do that Ctrl+C, or you could right click and then copy. Alright, so now once you are done with that, you can come back to your desktop and search for environment. Okay, so you can just tap on your Windows key and then search for environment, and then you see edit the system environment variables. So you open that, come to environment variables here, alright, and then on path you click on edit. Ensure you highlight path first, then you click on edit. Okay, then you click on new, and then you paste here, alright, and then click OK. You do that for the first one, the user variables, and also you come to the system variables, click edit, remove the highlight from this by just tapping on anywhere, click on new, and then come here and then you paste. Okay, then click on OK, 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 and we are okay. Alright, so now we are done with that. Let's verify that Git has been successfully added to all the directories, added perfectly fine, on the path. So we can search for terminal. You can either use the command prompt or the Windows PowerShell. So you open this, okay, and then you can just type Git. So once you see this, it means Git has been successfully installed on your computer. Alright, so now that we are done with that, the next thing we are going to do is that we are going to create a GitHub account. Okay, so you can come to your browser, any browser of your choice, and you go on github.com. Okay, so this is the site. So you click on sign up if you don't have an account before. Alright, and then right here, okay, so welcome to GitHub. Let's begin the adventure. So you put in your email here. So debug institute at gmail.com. Alright, so click continue and then create a password of choice. Okay, so take note of this. Make sure it's at least 15 characters or at least 8 characters, including a number and a lowercase letter. So you must ensure that you have characters and numbers, right? Lowercase letters in your password, and it can either be 15 characters long or this other condition here. So once you are done with that, you can click on continue and then enter a username of your choice. Okay, so debug 1 is available. And when you're done with that, would you like to receive product updates and announcements via email? So you can decide to put Y for yes or N for no. Okay, but purpose of this video, I'll put Y for yes. So let's solve this puzzle to verify that you are human. Imagine computers asking us, computers want to verify if we are human. Alright, so pick the spiral galaxy. So spiral galaxy, and spiral galaxy. Okay, I think there's one more. Okay, so we are almost good to go. So once I create on create account, I'll receive a mail on this my email right here. So let me check my mail if I have anything new. Okay, so I've just received my launch code. This is my launch code. So it's 26894973. So 26894973. Hope I'm correct. Okay, so now we are done with that. So just quickly answer these questions. How many team members will you be working with? So for these, you can actually just pick anything and make changes as you go along, right, from a profile setting. So for now, let me just select 5 to 10. Are you a student or a teacher? Well, a teacher, but for the purpose of this video, right, you guys should select student. So what specific features are you interested in using? Okay, so collaborative coding, automation and continuous integration and continuous development, security, right, client apps, of course, community. You can actually select all, right? There's no harm actually in doing that, and then you click continue. Okay, let's see. So continue for free, and we are ready. Okay, so congratulations, you have your GitHub account set up. Okay, so this is what will be housing our remote repository. Okay, so let's quickly create a local repository. Okay, so the IDE, the integrated development environment of choice of using, is the Visual Studio Code. Okay, so you can install the VS Code from this site, code.visualstudio.com/download. All right, and then for Windows, just click on Windows and you'll have this package downloaded and just install it. It's quite straightforward. Okay, so now once you have VS Code installed, you can open it up. All right, so let us create a new folder for our project. All right, now take note, most of the time rather, right, your projects are going to be in folders. Okay, so let's create a new folder for our project. So we can come to open folder, right, and here within my local disk, now if you look, I have all my project files in my C drive, and then I created a folder called project files, and then I have, well, project 1 here. Okay, so I can let me see, I can create a new folder here and then name it project 0. Okay, so let me select that folder. So the project 0 folder will be opened in my VS Code. Okay, and then I can decide to have files within them. So let me call my first file debug, or let me just call it welcome.txt. Okay, now of course when you're working with Flutter subsequently, you're not going to be using txt files. It's going to be an extension .dart. Alright, so let's just have any text here for now to just explain the whole extent of what we are doing. Alright, so let's have this, right? So good day, gentlemen. Alright, so just have a little text here, and then seeing this white icon thingy there means that you have not saved the file yet. So to save, I can simply do Ctrl S, okay, and then that white dot only there. So we have this file saved. Alright, so let us try right now and let us try and push our local repository and keep it in our remote repository. Are you ready? Okay, so let's get started. So to do that, we'll open our terminal. Now you can see that this terminal is quite similar with the one we used earlier. Alright, when we tried testing if Git was installed. Alright, so this is just an instance of this. Is an instance of this, right? They are one and the same thing. It's just a built-in terminal within the Visual Studio Code. So you see we are under C, project files, and project 0. Okay, so now that we're here, let us try and set things up. So the first thing we are going to be doing, right, if you remember, we have some commands that we are going to follow. Okay, so we have this series of commands that we're going to be using, so these are the Git commands to upload a project on GitHub. Okay, so take note, these first 3 commands we're going to be using is just a one-time thing. We're going to use it to set up our configurations for our GitHub, okay, on our local device. So let's get back on the video. Okay, so the first command there is git, right, config global init.default branch. That's me. Alright, so what this command means, okay, and there's something called branch in Git, right? Most of the time we don't see main branch or master branch. Now to just quickly explain this, alright, because it will make more sense later on. Okay, but for you to just have an idea right now, the local repository have its default branch set to master, whereas the remote repository have its default branch set to main. Okay, so if we're to push our project, what will happen most of the time is that 2 branches will be created automatically on a remote repository. You have main and you have master, right? But I don't actually like that procedure. I prefer to just have a single branch there, and then at any time of my choice I can create more branches. Okay, so by doing this git config hyphen global, it's saying initialize default branch to main. So what we are doing basically with this command is to initialize our default branch on our local device and set it to main, so that anytime we push, it can just effectively synchronize and we'll have just a single branch out there. Okay, so you having a response means it worked properly. So the next command we use is git config -- global space user dot name, and then you put in your username here. Just now I used debug 1. Okay, and then next git config. Now there's no need for you to memorize these things. Alright, you can create a text file and then just keep these commands there. There's no harm in doing that. Okay, user.email space the email you use in registering your account. So debug institute@gmail.com. So take note, you must give the same. If there's a space, give the same space there. If there's double hyphen, use double hyphen. If there's a full stop here, use a full stop. Now where I'm using quotes, quotation marks, right? Single quotes, double quotes, anyone. So anyway I'm using quotes, put quotes there, alright, or else it might not work as you desire. Okay, so now what these 2 commands here mean, right? They are used to set the author name and email address respectively that will be used in your commits. So what that means is that for every commit you'll be making, for every push you'll be making to send your project to your remote repository, it will be this username and this email that will sort of be on the author name. Think about a book, right? You usually see the author name there. Alright, so in that same way, when you make a push, it will be the name and the email that will be attached to that commit message. Okay, So now that you're done with that, the next thing we'll do is git init. Alright, now what this command will do basically, okay, is to start a new or an empty repository. Okay, and this will initialize the current directory as a git repo. Okay, so remember I mentioned that git repo, git repository, one and the same thing. So I might be using the word repo for repository. So this is a directory, okay, and then we said it will initialize the current directory as a git repository. So what that means is that the moment I run this command git init, this current directory I'm on will now be a git repository. This is what will make this project we are on a git, a local remote, right, for git. Alright, so another command we are going to be trying out is the git status. Okay, now this command basically, it will list out the files that have to be committed. Alright, it will just basically help you to know if you are currently tracking your main branch or your master branch. So if you notice, it's saying here on tracked files have welcome.txt. So this file right now is not yet tracked. Alright, and we'll see how we can track that file using the next command. So by doing git add space, we could do welcome.txt. So by doing this file that we have right now will be tracked. Okay, what it simply means is that it will be sort of ready, to be committed on and then to be sent to a remote repository. Okay, so you could do this, but what about in a situation where you have over 1,000 files, right, with series and series of code? You will not want to do this, right, because by doing git add and then just welcome.txt, it will be just this file that will be, tracked. So if you have multiple files and you want to just have all of them tracked, you could just do git add space dot, and then to have all files tracked. Alright, so the next command we're going to be using is called the commit command. So we're going to do git commit space and then we have here our commit message. So I can say anything, you can actually type in anything within this string in the commit message. So I'll say this is my first commit message. Alright, so I hit enter. Okay, so now this is git commit -m, which stands for message, and then the git message. Now what this command does is to basically record changes to the repository in the version history. Remember we talked about the version history, having to roll back to historical versions of a project. So this git commit will basically serve more like a checkpoint for our project, right? So that whatever changes that we made after, we can always roll back and then get the current state of our file. So what the git commit code, or rather command, will do, right, is to just record changes to the repository, that a change has been made, and then this will be the description on that commit message. No worries, as when I push, you see where this falls in. And then now that we are done with that, the next command we'll be using is the git remote add origin. Okay, now pardon me, I think I will need to increase the font. Right, this will be better, I believe. Okay, so git remote add origin, and then the next thing that comes in here is the remote repository project link. But right now we don't exactly have that link on our on our fingertips. So let me try and get that link from our remote repository. Okay, so how do we do that? We'll create a repository on our using our GitHub account. Now I mentioned by using the git init, this is our folder, which was a folder before, right? By using the git init command, it then makes it a repository, precisely a local repository. And then when we create a repository on our GitHub account, this is our remote repository. Alright, so it's be from here that I'll be able to get our remote repo link. Okay, so the first thing we'll be filling here is the repository name. So we can just call it the same thing we have here, project 0. So we can do project 0. Okay, and the next is the description that you would want on the project. So you can observe that it is optional, so you can decide to put some little details here, right, for maybe other users that would go through your project to have perspective, to have an idea on what your project is about. So you can decide to put in a description here or not, and of course for your own consumption too, right, because you can have lots and lots of projects and you would forget exactly what your project was doing. Okay, so in the description you can just put a little bit of info on what your project is doing. And then next we have some access level here, so you can decide to make your project public or private. Now if your project is public, it means anybody from anywhere, all right, can view your source code, all right. And then if you make it private, it means nobody will be able to view your source code. Now you can think of this public and private just the same way that I mentioned on open source and closed source. Now when it is public, it's safe to think about it that it is open source because everybody can gain access to your source code. And then when it is private, it is closed source, meaning nobody can gain access to your source code. Now take note, when you make your project private, of course, what about in a situation where you would want users to also, many other persons, maybe 2-3 other persons, to have access to your project? Now there's something called collaborator. So when you make your project a private project, you can then add collaborators. So even though the general public don't have access to your repo, those collaborators will be able to have access to your repo and then also to make changes and edits to your repository. So that's what this is all about. So for now, let's just make it public. Okay, and then these other things are optional. So you can initialize this repository with a readme file. The readme file says here is where you can write a long description for your project, all right? And then you can add a git ignore file, and then you can choose a license. No worries, as we progress, we'll talk about this more in depth. Okay, so now that we are done with this, so let's create a repository. So we click on create repository. All right, so we have our remote repo link right here. So you can copy this by just tapping on this button here, and to be copied to my clipboard. All right, and then we can come here and then paste it. So once you just tap on your right button on your trackpad, it pastes it, or you could do Ctrl+Shift+V and to paste it also. So hit on enter. All right, so this command basically what it will do is to link our local repository to our remote repository. So you can see here saying git remote add origin, and then we have this link. So this will successfully link both of them together so that any push command we make here, it can know exactly where it will be going to. Right? So the final command we are going to be using is the git push space u upstream origin and then main. And then this command will push our local repository to our remote repository. Okay, now because we are running this for the very first time, we will have to, okay, so I have here invalid username or password. Okay, I know why this error is coming up. No worries, you will not face this actually. Let me run it one more time. Okay, so now that you've run, now no worries, you won't face this error at all. Okay, now once you run this command git push, okay, you'll see a pop-up menu, all right, which say sign in with your browser, sign in with a code, or you could use a personal access token. Right, so let us sign in with your browser. So it says please complete the authentication in your browser. So you come here, open your browser, and then click authorize git credential manager. So once that is done, you could just go back and then you would see that your project has been pushed successfully. Okay, so let's see if it really worked. So let's come to our GitHub, to our remote repository. So for now, you see, because it's empty, we have this series of commands telling us how to just set up things. So let us reload this page, and you see we have our file successfully pushed here. So you can see the branch I was talking about, and it's just main branch. Okay, and then we have the file welcome.txt, and look at this, we have our commit message. Okay, so if we open this file, we have good day ladies and gentlemen, you are welcome to today's class. And if I go to my local repository, we have good day ladies and gentlemen, you are welcome to today's class. So our local repository has been successfully pushed to our remote repository. Okay, so before we finish this video, I would just love to show you guys how you could further update your remote repository. Say for instance, you've made a push, a commit, and you want to keep adding features to that particular project and synchronizing your local repository with your remote repository. So let us do one more thing. Okay, so let us create one more file. So call it congratulations. Right, say good job. Okay, have successfully come to the end of today's video. Okay, so look at this, the icon showing here, meaning it has not been saved. So do Ctrl S and get saved. Alright, so now let us make a push one more time. Okay, so like I mentioned, those series of commands we used earlier, right, you don't have to bother yourself with it all the time, because when you want to now make subsequent push, alright, on this project, all you need to just do is to do git add. Alright, so let me just add just a single file, which is just the congratulations, since that's the only change we've made. Okay, you have to ensure it's the right spelling. Alright, so it's become tracked right now. If I do git status, you see it's saying changes to be committed. So there's a new file, congratulations.txt. This file is ready now to be pushed. So we'll do git add, and then we can do git commit, and then say the test commit. Then next command is git push. Right, so you notice that the first time we did git push -u origin main, right, but subsequently all you just need to do is to do git push. Then your files will be successfully pushed out there, and then you have, okay, so reloading, you see we have congratulations.txt with a commit message of just now, and then we have welcome.txt. Alright, so that will bring us to the end of today's video. I hope you enjoyed your class. Alright, so see you guys in the next video. Thank you.